Good afternoon, everyone. I'm sure you all must be hungry. You have to bear with me for the next 10 minutes. And of course, I'd first like to thank Shailesh sir for this opportunity, and of course the other delegates here who have come here to listen to me. This is a different topic that I will speak on for the next 10 minutes. It's about earthquake impacts on moraine dam lakes. I'll be mostly covering the Gulf processes and the Gulf triggers, earthquake and glacial lake outburst trigger mechanisms, Gulf hazard exposure in the Himalaya, and I'll also be looking into two specific zones. One is the Uttarakhand and Himachal Pradesh, where we will be looking at the distribution of glacial lakes in high seismic hazard zones, or source zones to be correct, and Gulf implication of Gorkha earthquakes, and of course, finally, I'd like to speak on Gulf risk reduction in Himachal Pradesh. So we all are fascinated when we look into satellite images or when we look into glacier characteristic terrain. We have a water body which looks really nice, tourist place and all that. But yes, this is how glacial lakes form. We have a body of ice, which with time it melts, and then the meltwater is basically dammed by frontal moraine, which is glacier deposits, and with time what happens as the glacier recedes, or the mass of the water, the ice mass is accumulated in the form of liquid water. So what happens in the present case, this is what it looks like. We have the glacier body here, we have the glacial lake. With time what happens as the glacier recedes, we have the bedrock which is exposed. We can use the remote sensing, which is a very useful tool to monitor the growth of these lakes. As you can see here, this is an optical image, Lancet optical imagery, where we can go back in time and see how the lake has grown. This is the first image is from 1994, and as the lake was 0.09 square kilometers, and then with time it has almost doubled its size, right? So what are the trigger mechanisms of Gulf? So you can see most commonly 80% of the Gulf events occur because there is an impulse wave, which is kind of a tsunami, or in a smaller scale. We have either some kind of a mass movement into the lake, which basically generates a tsunami kind of a wave, which overtops the frontal dam. And finally, we have flood downstream. So one of the major triggers are earthquakes. To be specific here, we can see these. If there is ground shaking, there can be failure or rupture of the frontal dam, and other causes can be, glaciers coming down from the hanging valleys or debris flows into the lake. So I'll quickly play this animation, which basically shows you how it happens. You can see there's this avalanche which struck this, and then we have an impulse wave which will finally lead to the moraine. So now, talking about earthquakes in Gulf, how are the mechanisms connected? We have many causes, but the primary cause of Gulf can be earthquakes. Or how is it connected? So we can see that earthquakes can directly lead to the rupture of the frontal moraine, and also it can lead to slow internal piping failures. But again, if you see, earthquakes can trigger secondary hazards. For example, it can trigger dynamic slope failures, which is basically landslides or avalanche, which are triggered by the earthquake, and then there is displacement waves which are created, and there can be rapid rise in the water level, and eventually leading to the rupture where hydrostatic pressure at the dam increases. So now if we look into the situation, how the glacier is behaving over the years. So this is one of the paper which was published in Science. We can see that most of the benchmark glaciers in eastern, central and western Himalaya, there has been glacier recession. There's been cumulative length change of these benchmark glaciers. So what does this mean? That the glaciers are losing mass. And resulting, because of that, what is happening is the hazard situation changing. Yes, of course, we can see this recent paper in Nature Climate Change, which says rapid worldwide growth of glacial lakes. But if you look at the numbers, you'll be shocked. The 50% increase in the glacial lake area and volume, from 1990 to 2018. It's doubled in its area and volume. So of course the hazard situation is increasing. There are more number of lakes, there's more hazard potential, and of course potential risk downstream. Very interesting study published this month in Nature Communications. If we look into the population exposure to glacial lake outburst floods, we see that most of the population exposed, the population is in high mountain Asia. And out of that, 32% of the exposed population is in India, right? And if we look into the numbers, it is 3 million people who are potentially exposed to glacial lake outburst floods. But now, if you look into this, how far is the risk from the glacial lakes? If you see the average distance, you can see the Himalaya, the green bar is Himalaya, so high mountain Asia. So we can see that within 5 kilometers there's already exposure of population, right? So what does it say? That with time, population is migrating towards higher elevation. And then we see that in high mountain Asia there is exposure already in just 5 kilometers, But in other mountain ranges we can see that it is not that high. Now if we look into the glacier inventory, this is the work which we have been doing. If we look into the earthquake source zone, we have here we have the zone 4 and 5. And if we look into the temporal growth of the lakes, we can see that in the year 1968, we can go back in time when we have imageries which are corona hexagon images, which allows us to go back in time. So we looked into the number of glacial lakes which were present in the year 1968. And we saw that there are 60 glacial lakes which are moderately sized, which are 0.05 above 0.5 square kilometers. By 1994, 27 new lakes formed. And just try to see where these lakes are forming. These lakes are forming here, and some are here, which is right at zone 5. So by 2020 we have 102 lakes, and then by 2016 we have 130. So we have matched our estimates with the inventory which is published by ISRO, and then we have similar results. So looking into the numbers, we can see the numbers have gone from 61 to 130, but in terms of area it has gone up from 1.9 square kilometers to 4.6 square kilometers. So where are these new lakes located? They are located in the Alaknanda and the Bhagirathi basin, mostly. And both these basins are in the zone 5 of earthquake. So here, if you see that it has been growing in Alaknanda and Bhagirathi basin, and altitudinal variations, we can see that most of the lakes have formed in the altitudinal range of 4,500 to 5,500 meters above mean sea level. So these are some of the data sets which have recently been available for the glacial lake inventory, one from ISRO and one from Wadia Institute of Himalayan Geology. So now we know that India, Uttarakhand has a lot of lakes in the zone 5. Now let us look back into some of these effects or impact of glacial lakes on moraines. So this is an example from the Gorkha earthquake, how Gorkha earthquake have impacted this particular lake in Nepal, which is called the Rolpa Lake. And to be noted that before the earthquake in 2000, the lake was lowered by 3 meters by engineering interventions. So what happened after the Gorkha earthquake? We could see that there is a lot of slumping and cracking that developed on top of the frontal moraine. And we can see a lot of boulders also got displaced from the moraine, which basically is disturbing the integrity of that particular damming structure. We also have cracking right at the frontal moraine, which is very crucial when it comes to safe potential Gulf events. Now let us look into another event after Gorkha earthquake. This is called the Imja. This is one of the most hazardous lakes in Nepal. And we can see that post-earthquake they have constructed this particular structure where they have tried to lower the lake by 3.5 meters, and we also have a community-based early warning system. But what was the impact of Gorkha earthquake on this particular moraine? We can see that a lot of boulders have been displaced from the frontal moraine, and of course we have a lot of lateral cracks that have developed. And most importantly, there was seepage. You can see there was seepage after the event. So now, these were all immediately after the Gorkha earthquake event. But can these earthquakes can lead to problems in the future or near future? Now we'll take an example of the 2016 transboundary event that occurred in China, had an impact in Nepal. But this was intensified because of the Gorkha earthquake. So now let us understand how. So we see this is China, we have Nepal here. This is the lake location, and the gloss started here and then started and impacted Nepal here. You'll be shocked to know that we have had a history of trough events in this particular basin. Here, this transboundary basin, which is called the Poikiu Basin. So this particular valley had previous trough events in 1964, 1981, 1983, 2002, and 2016. All these trough events have occurred from this particular lake, which is called the Sirenmaku Lake. You can see it's a huge, big lake. But you'll be shocked to know this 2016 event occurred from this lake, this tiny lake next to it. Which is unbelievable. It's just 100 times smaller than the lake, the previous events. But the impact of this particular event was equally similar to what this bigger lake has created. What is the reason? The reason is we had the Gorkha earthquake 1 year before to this event, and there were a lot of landslide deposits which were easily available for the Gulf to transport. So this is our work we published in Scientific Reports in 2022, last year. So we can see the landslide density map here. And yes, of course, this is where the lake is, and this is the boundary. And we can see that landslide density was very, very high on top of this. So I have maybe 2 minutes more?
Yeah.
Okay. So this actually started, and this destructed the Bhutkoshi hydropower station, which is in Nepal. You can see how destructive this event was, even though the lake was so small. And of course, earthquakes, this trough actually led to reactivation of the landslides that was triggered by Gorkha. So these were along the Gulf channels, but when the Gulf happened, during the Gulf event, they reactivated the landslides. So overall, this is what happened here. There was a debris flow event that went into the lake, there was overflow of the lake, and finally there was a Gulf event. And so if you look into the cross-section in one of these cross-sections here, this was the cross-section before the Gorkha, and you can see how much, that almost 8 meters, almost 80 meters of sediments are deposited during the Gorkha landslides at places. So what is it? There are a lot of loose sediments available for the little water that has come to transform into a hyper-concentrated or a debris flow. So interestingly, there was an early warning system which failed in 2021, but we have a new early warning system in this valley, which is constructed after the flood event in 2020. So now it is functional, and of course we have certain monitoring system at the dam site itself. So India is equally exposed to transboundary Gulf hazards. We can see India shares its border with China, Nepal, Pakistan, Bhutan, where a lot of glacial lakes are present. All of them are hazardous. And then now, most importantly, is to look into how hazardous they are. So finally, I would like to talk a little bit about the disaster risk reduction, how we can use modeling techniques to look into glacial lakes hazard reduction before it is actually implemented in the ground. So here we have taken an example. This was published, we recently published this paper in JGR, where we looked into the Gepang Lake. This is the largest lake in the state of Himachal Pradesh, and it has been in news, and it has been a hotspot where it is potentially hazardous. So importantly, what we see this glacial lake, we have a village called Sishu, which is 10 kilometers downstream, and we have a helipad, and it is a very important site because there's tourist attractions, and there are people coming in every year. Now looking at the growth of the lake, you can see it started from a tiny little lake, and now we have a lake which is 2.3 kilometers long. Just imagine a small tiny pond in 1990s. Now we have a 2.3 kilometer long lake which is present right there. Now here in this we try to look into different ways we can mitigate or reduce the hazard. What we try to look, we try to model different avalanches that can hit this particular lake. And what if we try to lower the lake by 10 meters and 30 meters? What effect it would have in terms of hazard potential, downstream risk? What we found is that if we reduce the lake by 10 meters or 30 meters, there is no overtopping of the moraine. So there is no wave, the tsunami wave which is being generated is not overtopping the frontal dam. So the risk has come down at the source itself. But again, when we are considering large magnitude events, you can see these are low magnitude and moderate magnitude events. The large magnitude events, there is overtopping of the water, but the risk in the Sishu village is significantly reduced. Now let us look into what is happening. So this is the lake before lowering, 0 meter lowering, there is no lowering. 10 meter lowering, we see that lake is looking something like this. And by 30 meter lowering, we see that the lake has shrunk a lot. Now what impact it would have at Sishu village when we lower it? We see that in moderate case, if we lower by 10 meters, the bluff would not reach. Yeah, this is my last slide. So 10 meter, there is no exposure. If we further reduce it to 30 meters, of course, there is no exposure. But if we look into large magnitude, we see that if we lower by 10 meters, it is significantly reducing the exposure. But if we reduce it by 30 meters, there is no exposure at all. So how can these be important? Now this is the first hydropower which was generated from a glacial lake. What they tried to do, they lowered the lake but generated electricity out of it to support the villagers, which are, maybe 120 households. They're getting the electricity from this particular lake. This is the new NDMA guidelines for Gulf. I would not like to read out all of it, but maybe I would like to read the last sentence. Earthquake being one of the causes of moraine dam failures, the frequency and magnitude of moraine dam failures and bluff will continue to increase. The current scenario of global warming and the present one of the greatest threat to people, right? So before I conclude, here are a few take-home messages. Earthquakes can be primary triggers of glacial lake outburst floods. Earthquake can be cause of secondary triggers like landslide, avalanches. And evaluating earthquake hazard must be an integral part of glacial lake outburst flood hazard assessment. And of course, disaster risk reduction measures significantly reduce the potential exposure. And finally, lake lowering should not be considered as the only solution. There are other solutions like involvement of the community, which is non-structural, basically talking to people, giving awareness, and then build resilience to the community. So I'd like to thank my funding agencies, my co-authors, and the projects on which I have delivered. So with the last statement that I would like to leave you all with is the vulnerability decreasing at the rate to offset the increasing potential hazard and risk. So there I answer.
Thank you, Ashim, for very interesting talk. I request all the speakers, Dr. Prakash, Dr. Mishra, Dr. Tan. Yeah, we can have 3 questions. One, yeah, you can start. You will start. I'll come back.
Good afternoon. My question is about the evacuation when we are talking. So means this is all like people said it's academic, but when we don't have any evacuation, like the high-rise buildings, we are not having the mock drills. Although this question should have been put after the NDRF and the NDMA. So what is the actual scene happening? Nothing is. Recently we had an earthquake, I think last month, and the channels were really showing a panic situation. The anchor was in the high rise and she says, "My neighbors, aa jao, kaisa ho gaya tha, kya ho gaya tha?" So how do we get out of this game, sir?
Yeah, I think we will.
Yes, sir.
Afternoon we can keep.
Yeah.
Someone. Yeah.
Thank you so much. Very wonderful, very interesting, informative talks, everybody. What I do understand from the talks is that it can't be predicted when earthquakes are going to take place. But what I saw from Dr. Mishra's slides was that of India, that the Himalayan region and the coastal region seem to be more prone. And about
Not
Delhi
coastal.
also, you mentioned it's along the river
coastal.
Yamuna, it's more prone. And okay, you can't predict, but one of the factors can also be climate change. My question is to Dr. Mishra.
No. Earthquake and climate change.
I think this is a very good question. In 2014, in current science, I have written that how climate change going to be a proxy of the earthquake and how the earthquake going to hasten the climate change processes. If you see that recently the Honorable Minister has given the statement in Parliament also that if the polar region in Himalaya, if the thicker ice sheet is melting, then the crustal load is lessening. And then there is the bouncing of the crust and then the micro earthquake modulation has been recorded. We have also published in Elsevier on paper on showing the Himalaya and polar. So this is the one fact. Second factor is that also the bigger earthquake of magnitude 8 and above, means 9, having a huge energy budget. They have the power to tilt the axis of the rotation. If axis of rotation is tilting, then there is a change in the abnormal circular motion. And if circular motion, then there is called Ritu Parivartan in geography book. So, but it has a very healing effect itself. After some times you have seen in the Andaman Nicobar tsunami, the earthquake, there was the tilting of the axis of the earth rotation and it was started to come to very quickly to the position. So both earthquakes, because it generates huge amount of energy, 9 magnitude is 56 gigaton of explosive energy generated. So it is the rightly now research is going on. Thanks.
So one more. Excuse me, sir.
Over there.
I'm Dr. Jagwanta Dixit from Sattar University. My question is to Dr. O.P. Mishra, sir. So, you said in one of the slides that we had two buildings. We have multiple buildings in Muzaffarpur earthquake, and one was tall, multi-story building, and the other one was kind of grounded. So, the damages should be attributed to the local geology, or the frequency of ground motion and the frequency of the building can be also be one of the parameters, in addition to soil geology, of course. Thank you so much.
Both factors are there. The foundational material at the site of the building was the weaker and very much amplifiable. So the earthquake shaking frequency matches to the frequency of the structural frequency, so resonance taking place. Or it was the lesser than the earthquake shaking frequency. So this amplification is dictated by the media, that is the foundational material, stiffness coefficient, weakness, fragility, all the things are there. It was not happening when there is a compactness is there and a structure is, its frequency, spectral frequency of the structure is more than the shaking frequency of that side.
Very briefly, you used the word earthquake proof. It could be earthquake resistant. That no structure can be earthquake proof. Resistance to some extent.
Very good question. You can tell that your watch is the waterproof. If the earthquake resistant structure for a particular earthquake is not damaged, then it is the proof of that magnitude of the earthquake.
That is English.
Sir, I just want to add on, I don't have a question. A very important fallout of the earthquake is the phenomena of the avalanche. Now, avalanche has been briefly touched upon by the last speaker, but I just wish to say that for the mountaineers and for the people who are especially living and working in the high Himalaya, as we call it, or the greater Himalaya, the avalanche which can be triggered as a result of an earthquake, primarily because of the vibrations, can have a very deadly effect. And some of the avalanches, especially the airborne avalanche, while the avalanche phenomena might stop in the upper reaches, but the destructive effect that it can have and the pulverizing effect it can have can be for very, very, kilometers down below. This has led to destruction of villages, railroads, and cities in the Alps and in the Andes. So I think when we talk about landslides, when we talk about glacial lakes, we should not forget that avalanches can also be triggered as a result of earthquake. Thanks.
Yeah, absolutely.
Absolutely.
I'll come.
So how do you account for these ancient forts which are 800 years old, 900 years old in Jaisalmer and other places, I mean, what's the construction technology?
There's no earthquake there, no.
In those
Days or is it more, primitive? Even with those primitive
construction technologies those buildings can withstand. I don't think any even 9 on the Richter scale can destroy the Jaisalmer fort.
I think you are right. If you see the indigenous structure made by our ancestors, they took a lot of their experiences, called the past experiences, and they make the foundational plinth area is so bigger, so that the earthquake, when the shaking comes, is they start not to absorb by the building, to deflect by building, or maybe it does not pass through the building. So they try to avoid the cracks of the ancient building, like Red Fort and all this. They took all the care for that. So it was very.
Just to add, just read the history how the foundation of Taj Mahal has been done. Yeah. So just read about it and how the the kind of wooden material which has been used, because it is on the bank of river Yamuna, which basically also produces fluctuations in the ground, and that technology is allowing Taj Mahal even after so many earthquakes has happened, but not even. So you have to have the elasticity in your building so that they can respond well.
Absolutely.
Yeah.
It also shows that you haven't had a great magnitude in 5.
Correct.
Because we are destroying our flora and fauna, that is also one of the cause of this problem.
And Rajasthan is seismic zone number 2.
Take care of our flora and fauna so that we can avoid this problem.
I think my colleague Dr. Sukhantara has already explained anthropogenic activities. But you see, it has, of course, it has the earthquake also caused the destruction of flora and fauna. And flora and fauna, how much impact on local effects of the earthquake, like the brackish water, the populations of the water, some type of there are the many things there, but these are the very localized effects for the flora and fauna there. This type of evidence was there, but the earthquake had a lot of the impact on flora and fauna destruction. But of course, we have to maintain the nature of this.
Yeah. I think, thank you very much.
Very nice
interesting session.
Very interesting.
And we'll come back at 2:15.
Yeah.